Hello, it's Carl here and welcome to another tutorial. This time we're going to jump into Blender and I'll show you how to rig a car using the Rigicar add-on. For reference, I'm using Rigicar version 2.3.0. So what exactly is Rigicar? Imagine you've got a fully modeled, polished car ready to go. You import it into Blender and now what? It would be great if it could move, right? So you could drive it around the scene, turn the wheels, maybe have it bounce over bumps. And that's exactly where Rigicar comes in. It's like your personal helper for rigging cars. You don't need to set up any bones, constraints or fiddle with parenting, just a few clicks and you have a complete rig ready to drive. If you love tweaking details, you'll be happy too. Rigicar lets you fine-tune practically every parameter. If you'd like to try Rigicar yourself, you can find it on the Superhive website, just search for Rigicar. The add-on is available as a paid version for around $22 depending on current promotions. If you don't have a car model yet, download one first. I got my model from Sketchfab, but you could also use Wire Wheels Club or Blend Swap to find a free one. And if you need a specific car, you can find some cool models at reasonable prices on CGTrader as well. Alright, so how do we go about it? Let's go step by step. Make sure the car's geometry is separated into at least the body chassis, brakes and the wheels. Often, models from the internet come with everything joined into one object, so you'll need to split them up. Go into edit mode and separate the wheels from the rest, for example, by selecting one wheel and pressing P and selection. If selecting is tricky, hover your cursor over a part and press L to select all linked geometry. It's also a good idea to separate the brake components, discs and calipers from the wheels, since in reality those don't rotate with the wheel. After splitting, you should have the body as one object, each wheel as its own object, and optionally each brake disc and caliper as separate objects. Now let's set up the centers of rotation for the wheels. First, check if a wheel's pivot point is already at its center by rotating the wheel. If it spins correctly around the middle, you're good. If something seems off, here's how to fix it. Select one wheel. Let's start with the front left. That wheel usually consists of the tire, the rim and maybe lug nuts or other bits. Move all those parts into a new collection and name it, for example, WHLFL, which stands for wheel front left. Hide the rim and nuts, leaving only the tire visible. Enter edit mode on the tire, select the last loop of edges on the rim of the tire and press Shift S and then cursor to selected. This moves the 3D cursor exactly to the center of the wheel. Exit edit mode. Now press Shift A and create a new empty and null object. Name it WHLFL. It should appear right at the center of the wheel. Unhide the rim and nuts, then Shift select them along with the tire. Finally, Ctrl select the new empty so it's the active object, then press Ctrl plus P and choose Object, Keep Transform to parent the selected wheel parts to the empty. Super! Now one wheel is prepared. To be sure, try rotating it around its center and see if the tire, rim and nuts all spin together nicely. If you notice something is slightly off-center, say the rim has a different center, you can use a quick trick. Add a copy location constraint to the misaligned part, like the rim. Set the target of the constraint to our tire, which has the perfect center, then click Apply on the constraint. The object will snap exactly into place. Now when you spin the wheel, everything should rotate correctly. Prepare each of the 4 wheels this way, each wheel in its own collection, with an empty at its center and all the wheel parts parented to that empty. For good measure, set each wheel's position to the origin 0, 0, 0 in the item panel after parenting. This zeroing out ensures the pivots are perfectly centered with no offsets. Sometimes, if a wheel's geometry center isn't perfectly aligned, you can get weird effects, for example with motion blur, or the wheel spinning with a slight wobble, kind of egg-shaped like in old cartoons. Resetting the positions eliminates that problem. Now let's handle the brakes. Select each brake disc and its caliper and move them into a new collection. For the front left wheel, call it brake FL, for the front right brake FR, and so on. You might ask, why separate the brakes if they sit in the same place as the wheels? Because the wheels will be rotating when the car moves, but the brake discs and calipers should remain static. In reality, they don't spin with the wheel. This separation keeps things realistic. The wheel spins, the brake assembly doesn't. Now organize everything else in the car. Everything except the wheels and brakes should be grouped, say in a collection called BODY. Create an empty object to serve as the car body's pivot. Make sure your 3D cursor is at the world origin. If it's still at a wheel from earlier, press Shift S and then cursor to world origin. Now Shift A and add an empty, naming it BODY or car or whatever helps you identify it as the car's main controller. Select all the car body objects, the chassis, interior, etc. and parent them to this BODY empty, Ctrl plus P and then Object. This gives us a main controller for the entire car body. At this point, for clarity, you might have a BODY collection with the car's body mesh, 4 collections for the wheels and 4 collections for the brakes. Now that our model is prepared, it's a good idea to save it and link it into a new scene to keep things lightweight. Save your car model, for example, rigicar.car.raw.blend. Then open a new empty Blender scene. Go to File Link, navigate to the file you just saved, and link in all the collections BODY, WHLFL, WHLFR, etc. After importing, you'll see the car appear in the new scene, but as collection instances, the geometry is linked from the external file, which means the scene is much lighter. Blender isn't keeping 2 copies of the same mesh data. You won't see individual mesh objects now, just empty objects representing each linked collection. Why do it this way? Because if you decide to change something later, you won't have to redo the whole rig setup. For instance, you could tweak the rim in the original file, update the linked instance in your scene, and the changes will be reflected, all without re-rigging from scratch. This is super useful if, say, a client decides to switch out the wheels after you've already set up the animation. Everything is nicely organized and the scene is light. But there's one snag. Rigicar doesn't quite get along with those linked wheel instances. When I tried rigging the car at this stage, I noticed the car sank into the ground. It looks like the add-on can't properly read the wheel geometry when it's an instance, probably treating each wheel as just a single point rather than the full shape. That makes sense given how linking works, but since we want to keep our lightweight, editable setup, we need a workaround. Luckily, there is one. We'll simply create proxy wheels for the rig. Basically stand-in objects that Rigicar will treat as the wheels for simulation. The easiest way is to use cylinders as proxies. Hide all the actual wheel objects except one wheel to start with. Now add a cylinder in the exact spot of that visible wheel. Shift A, then Mesh and Cylinder. Rotate the cylinder so that it aligns with the wheel's orientation, so its round face is oriented like the wheel, and apply that rotation. Next, add a copy location constraint to this cylinder and set its target to the corresponding wheel's collection instance. This makes the cylinder stick to the wheel's position even if it moves. If the cylinder is blocking your view of the wheel, go to the cylinder's object properties, viewport display, and set it to wireframe so it's see-through. Make sure the cylinder is roughly the same size as the tire. It doesn't need to be perfect, just close enough to represent the wheel. If you want to be extra precise, you can add a bevel modifier to the cylinder to round its edges, to better match the tire's shape. Also, if the cylinder's size was scaled to match the wheel, don't forget to apply the scale. Now the cylinder should be perfectly aligned with the wheel. At this point, the copy location constraint has done its job aligning the cylinder to the wheel. You can apply it. Next, let's parent the wheel instance to this cylinder. For example, select the WHLFR wheel instance and then shift-select the new cylinder you created at that wheel's location. Press Ctrl+P and choose Object, Parent without Inverse. You can rename this cylinder to something like Control WHLFR for clarity. Now the cylinder carries the real wheel. If you have 2 different sets of wheels, say the front wheels differ from the rear wheels, repeat this proxy setup for one of the rear wheels as well for the rear right wheel. If all 4 wheels are identical, you can just duplicate the proxy cylinders for the others or continue with the 2 you have. The rig will copy them to make all 4 anyway. So hey, our model is prepped to perfection. Now it's time for the main event, rigging it with Rigicar. First, make sure the Rigicar add-on is enabled if you haven't done this already. Go to Edit Preferences, Add-ons, search for Rigicar and check the box to enable it. If you purchase the add-on and it's not showing up, click the Install button in the Preferences and load the add-on file from your disk. Once enabled, you should see a Rigicar panel in the 3D Views sidebar. Press Rigicar menu in the toolbar. Select the main body object of your car. In my case, that's the BODY empty we created for the chassis. It's important to have the car's null body selected when generating the rig. In the Rigicar panel, click the big Rigicar button. The add-on will think for a moment and voila! A rig appears! Blender will add various controllers, including a path curve for the car to drive on and some empties and objects for controlling the suspension and wheels. In the Rigicar panel, you'll also see options for the wheel setup, like whether all 4 wheels are the same or if front and back are different. For a typical car, choose 1x4. 1 type of wheel, 4 total. Now we need to tell Rigicar which objects are the wheels. Make sure the wheel mode is set to 1x4 if that's what you chose. Select the proxy cylinder for the front right wheel. Rigicar uses the right side of the car as the reference. Once you select that front right cylinder as the wheel, the add-on should automatically pick up the other wheels. It duplicates that proxy for all 4 since we chose 1x4. Keep in mind, Rigicar at this point is only using the cylinders our proxies as the wheels, not the actual wheel geometry we parented to them. Ensure the wheels are oriented correctly, the rig will give you visual feedback. In my case, I had to quickly adjust the orientation by rotating the proxies around their local z-axis. Now our rig knows about the proxy wheels, but we want our actual wheels visible and following along. After generating the rig, a new collection, often named something like Rigicar collection, was created, containing all the rig objects, including wheel controllers for each wheel. These might be unselectable by default, so in the outliner, enable selection for the rig objects, toggle the filter to show the selectable checkbox, and make sure it's on. Now for each wheel, select the real wheel instance and its corresponding rig wheel object. Then press Ctrl+P and choose Object without inverse to parent the real wheel to the rig's wheel controller. The real wheel should snap right to the controller's position. Do this for all 4 wheels. Now the rig's wheel controllers will carry the actual wheels and our proxy cylinders have done their job. Now the cylinders serve as proxies for the wheels, meaning you can swap out or edit the actual wheel geometry later in the source file and it will update here, without messing up the rig. That's the beauty of a procedural setup. What about the brakes? Well, here we need to get a bit crafty. But don't worry, it's nothing scary. In Rigicar's options, there's that little anchor icon that shows us the armature. You'll see where everything's positioned, but there's no way to hook the brakes up directly through the UI. No big deal. Just select your brake object and the rig, switch to pose mode. Just make sure the rig is the active one. Then hit Ctrl+P and choose Bone Relative. If your brake ends up flying off somewhere weird, just make sure to tick that Keep Transform box. For our car to know where the road is, we need to provide a ground object. If your scene already has a ground or terrain, great, you can use that. If not, add a flat plane to the scene and scale it up to cover a large area. Apply the scale, so that Rigicar calculates things correctly. In the Rigicar panel, find the ground setting and select this plane as the ground object. You have to select an actual mesh object here. Selecting a whole collection won't work. You can even make the plane a bit uneven by adding a displace modifier or sculpting some bumps to test the suspension. But to start, a flat plane is perfectly fine. The Rigicar rig does a lot automatically, but you can optionally enable the car's suspension physics for extra realism. In the Rigicar panel, click on Dampers. Now the wheels will have independent suspension movement. The car will sit on its shocks, meaning the wheels can move up and down relative to the body, just like a real car suspension compressing and extending. So what can we control now? Mainly the car's motion along that path. Rigicar created a path curve for us. You'll see a dashed line or similar in the scene. You can animate the car moving forward by simply moving it along this path. In fact, the rig gives you a convenient slider, an animation parameter for position along the path that you can keyframe. As the car moves, the wheels will automatically rotate at the correct speed based on the distance traveled. No need for you to manually keyframe the wheel spin. Steering is also handled if you use the path. The front wheels will automatically turn left or right following the path's direction. The car body will even lean a bit in the turns, and with the dampers on, the body will tilt back when you accelerate and dip forward when you brake. All of this happens without you animating anything besides the car's forward movement. In the Rigicar panel, you can dial in various settings to adjust these effects. There are many parameters to play with if you want to fine-tune the behavior. But to start off, you actually don't need to touch any of these. The default settings already give a nice realistic result for a basic car animation. And you did all this without manually animating the wheels or suspension at all. Rigicar handled those automatically. Pretty cool, right? The rig is quite flexible and powerful, letting you focus on designing the motion while it handles the physics nuances. I hope I managed to guide you through the whole process of rigging a car with Rigicar in a clear and accessible way. If you enjoyed this tutorial, feel free to subscribe to my channel. Thanks for watching and see you next time!